Good afternoon, General Chemistry. We are picking up with part 2 of our notes talking about redox reactions. So remember, redox stands for reduction and oxidation reactions. And a redox reaction is where electrons are being transferred. So we've done a lot of work with this in class. Some of this is review, but let's dig into it. Many redox reactions are single replacement reactions, and we reviewed what these are, but it's where one reactant is elemental form and then it takes the place of another reactant in a compound. So again, A would be our elemental compound, BC would be the compound, and A and B are going to switch places. That's a single replacement reaction. In a single replacement reaction, the single metal is oxidized and the compound is reduced. Okay, so let me get my pointer. That means that when we look at A is going to be oxidized and B is going to end up being reduced. Okay, or I think and we'll talk about, again, we use oxidation numbers to determine why that's happening or who that's happening to. So if we take a look here, magnesium plus copper sulfate, CuSO4, we're going to get a redox reaction. Copper is going to become a metal and magnesium is going to go into the reaction. So let's talk about how we determine, again, how something is reduced or oxidized. So here, magnesium, its oxidation number would be 0. Here again, we start with what we know. So oxygen, they're each worth -2. So we have 4 of them. So I'm going to write it 4 times. Copper, then in this case, is going to be +2, okay, because sulfate SO4 has to be -2 overall. And if we look up copper on our pink sheets, it's going to be +2. Then sulfur ends up having to be +6. Okay, we look here, copper is now 0. Magnesium, oxygen, so oxygen's still -2 each. It's a -2 each. Oxygen, now we got a +2 from magnesium, and it's going to be +6. All right, so then we can see that magnesium's going from 0 to +2. Copper is going from +2 to 0. So remember, if the number is going up, it's oxidized, so magnesium is oxidized. And if the number is going down, copper sulfate is being reduced. Okay, we are using single replacement reactions to determine an activity series. So we're going to be doing this today in class. So remember, if it's this type of reaction, the metal, it starts as metal gets oxidized, and then the metal inside the solution gets reduced. All right, let's take a look then at what an activity series is. So an activity series is a list of metals from the most likely to react to the least likely to react. So activity just means how reactive it is. The more reactive the metal will take the place in the compound. So if we look here at this picture I have, all right, remember on that reaction we took a look at, and we're going to take a look at it in a second, between copper and iron. All right, in the beginning, iron is up here, and copper is way down here. Okay, and in that first reaction we looked at the beginning of the chapter with the blue solution and the piece of iron nail, or we used a paper clip, iron took the place of copper in the solution because it's higher than, it's more reactive, it's higher. All right, so this is a handy thing. You can always look these up online too, and we're going to be creating our own activity series. So the higher up on the list, the more reactive it is. Let's take a look. This is a silver solution. So we have silver and nitrates floating around in the solution, and then we have a piece of copper metal. Okay, now copper metal is above silver on the reactivity series. So if we go back one, here's copper, here's silver. So because copper is more reactive, it's going to take its place in the compound. So we see here then silver takes the place, exchanges electrons with copper. And if you look at the picture, it's just like the lab we did. We see silver starting to plate on this piece of copper metal. And look at the solution ends up turning blue because silver is plating, and then we get copper in solution. So it turns into that blue solution we're used to seeing. All right, and here's the chemical equation on the bottom. But it's a really good thing to think about what's going on at the molecular level. All right, let's talk about half reactions. So you saw a little bit of this in the packet, but half reactions are the result of splitting up the chemical reaction into oxidizing reaction and the reducing reaction. So here's an example. We have copper 2 plus zinc gives us copper and zinc plus. So if we look, zinc is going from 0 for an oxidation number to +2, so it's being oxidized. Copper is from +2 going to 0 for an oxidation number. So we have to figure out what's being oxidized. We said we're going from 0 for an oxidation number to +2, so that's our oxidation half reaction. And the half reaction for reduction, copper is a +2, going to just a 0, elemental copper. Okay. When we balance redox reactions, we must make sure the elements are balanced and the charges are balanced. Okay, so we have to do both. We have to balance the charges and balance the elements. So to balance charges, we add electrons. So if we take a look here we got 0. I'm going to switch to my pointer. We'd have 0 for an oxidation number on this side of the reaction. Okay, so I think we're splitting it in half. Here we have +2 for the oxidation number from zinc. Now we have to add 2 electrons, which gives us a charge of -2, and that's going to cause the overall charge to be 0 on this side. So it has to be 0 on both sides, or you have to balance. It has to be the same on both sides. Okay, so let's look at the reduction reaction. Here we start with +2 for our oxidation number on copper, and we have 0 over here. Okay, so what do we have to add to the other side? We need 2 more negative charges. Oh, sorry, did I not have that on there? So we have to add 2 electrons to this side in order to balance it out. So then we have a -2 charge, and they're going to equal 0 overall. They're going to cancel each other out. Okay. When you make sure electrons match on each side and add them together. So now we're going to balance this guy. If you notice, we have 2 electrons on the product side and 2 electrons on the reactant side. So whatever's on the left has to also be on the right. So then we can cancel them out. So we cancel out the electrons, and then we just write everything to the right of the left of the arrow and everything to the right of the arrow. So Cu 2 plus, zinc, and then Cu, and then zinc 2 plus. So in this case, we didn't have to really change anything from the reaction. It already was balanced. All right, practicing balancing redox reactions. So the first thing we need to do here is figure out oxidation numbers. All right, so zinc is going to be 0. Okay, remember we said it's oxidized if it's the metal gets oxidized. Here we're going to have -2, -2, -2. Silver has a +1 charge, and then nitrogen is going to end up having 6. So plus 5. Zinc, silver 0, -2, -2, -2. We have 6 total, -2, -2, -2. And zinc has a +2 charge. Here then we're going to have it be, we got 2 of them, so it's going to be 5 again. Okay. All right, then we look, zinc is going from 0 to +2. Silver is going from +1 to 0. Everything else stays the same for the oxidation number. So then we write our half reactions. Here's the net ionic equation. I just took out anything that wasn't reacting, so NO3 wasn't doing anything. So I have a net ionic equation that looks like this. So first we have to write our half reactions. Oxidized, we see that zinc is going from zinc to zinc 2 plus. Okay, and we can pull that from right here. Zinc is going from zinc to zinc 2 plus. Silver is going from +1 to 0. Okay, so here's our oxidized because the number is going up, reduced because the number is going down. And I made sure that I balanced my equation, so we had 2 here and 2 here. Second step is to balance charges using electrons. Okay, so we have a +2 charge here, a 0 charge here. So what we have to add 2 electrons to this side to make it 0. Silver, we have 2 of these, so we have a +4 here and a 0 here. So we have to add 4 electrons because we got 2 of these. Now we have to pay attention to the coefficients. So now we have to times this whole thing by 2 because we want to make it 4 because we have 2 here and 4 here. So we want to make this into a 4. So we times everything by 2. 2 zinc, 2 plus, and 4 electrons. Now we can add these together. Add the half reactions together. The electrons will cancel, so we just have to write the stuff that's left. Okay? So we end up writing 2 zinc. Oh, sorry, I didn't cancel them out, but they're going to cancel because they're on both sides. So then this is our final reaction. We take out those electrons because they match, and then we write a final balanced reaction. Okay? So that's where we're going to stop today. You are going to have a worksheet where you have to balance an equation and practice assigning oxidation numbers. And we're going to take a look at that activity series in lab. All right, see you in class.